Welcome to Chibuzor Math Physics. My name is Augustine, and I will be taking you through general gas laws, or what I have called gas law exposed. So we will be looking at different kind of gases. We'll be looking at Boyle's law, Charles law, Pressure's law, and by extension, Avogadro's principle and Datums Law of Partial Pressure. And we will also have numericals and their equivalent problems and calculations. I hope you will enjoy it. Let us dive into it. When we talk about gas laws, these laws only apply to matter in gaseous state. They apply to matter in gaseous state, and a gaseous state is understood as one of the four states of aggregation of matter, together with the solid, liquid, and gas, or what I call the plasma state. Substances in a gaseous state are called gases, and these are characterized by having their constituent particles little joined together. That is, they are expanded along the container where they are located to cover as much as possible the available space. So the available space where they are located within a container is expected to be covered. So when we talk about gaseous state, we should always remember the four state of aggregation of matter. We talk about the solid, we talk about liquid, and we talk about the substances like plasma. So I will be looking at these states, and by considering these laws and how their pressures and the initial and final velocities is being accelerated, and how we can actually apply these laws in our day-to-day activities. Now, there are things that we have to remember when we talk about gas laws. These laws determine how three interdependent variables, that is the volume, the temperature, and the pressure, are being linked or connected or related, and how they affect one another when a gas is heated or when a gas is being cooled. So things you have to remember: a gas can be heated or a gas can be cooled. And if this happens, the volume increase or the volume decreases. It could be that the temperature or the pressure or even the volume of these are constant depending on the law in which we are applying. So Boyle's law basically explains the relationship between the pressure and the volume when temperature and molar mass are kept constant. So the temperature and the molar mass of the particle is constant, and that is Boyle's law. Remember that the pressure of a gas is inversely proportional to the volume of the container. What we mean is that if we can try to change the definition, you can say that it states that the volume of a fixed mass of a gas is inversely proportional to the pressure, provided the temperature remains constant. So PV is equals to K. K simply means constant. So pressure multiplied by volume is constant. And we know that P is equals to K divided by V, because pressure and volume have an inverse relationship. They have an inverse relationship. Remember from our definition, we said that the volume of a fixed mass of a gas is inversely proportional. So there is an inverse relationship between pressure and volume. You will understand this better when we dive into calculations and other numericals. So we will say that P1 V1 will be equals to P2 V2, because the first pressure and the first volume will just give us the equal pressure of the second pressure and the second volume. Let us consider this graph. This is general Boyle's law, Boyle's gas law graph, and in this graph we can see that pressure volume, the first pressure and the initial volume is constant because the temperature is constant. Of course, T3, that is the third temperature, is greater than T2, and is greater than T1 because T1 is less than T2 and is less than T3. So this is what we have. It is a kind of instantaneous graph that we use this graph to consider PV to be constant. And in the second graph, we can see a straight line graph that shows that inverse relationship. When P, which is the pressure, is constant, then we multiply with 1 over V because this is an inverse relationship. And when we have a horizontal line, we simply have P or V because PV will be equals to 1 times K because it is what? Constant. This is just what we are talking about. There is an increase in temperature. Charles' law, the same thing, explains the relationship between volume and temperature. And when pressure and molar mass are kept constant, the volume of a container is proportional to the temperature. The volume of the container is proportional to the temperature. You will understand this better when we be talking, calculating the amount of molar mass that is exerted in the container when the temperature is constant or when there is an acceleration, when there is a change in that container. So this will be what we will be dealing with, but it is basically good for us to start with these terms so that we will get the definitions and what we'll be talking about later. So Charles' law basically states that the volume of a fixed mass of a gas at constant pressure is directly proportional to its absolute temperature, provided that the temperature is kept constant. So the temperature is kept constant when there is a volume of a fixed mass of a gas at a constant pressure. Then we are talking about Charles' law. Mathematically, we can express this definition as V, which is a volume divided by temperature, is kept constant because volume is proportional to the temperature. So we can do our calculation by asserting the fact that V1 divided by T1 will give us V2 divided by T2. And that is how we calculate this volume of a mass using Charles' law. Of course, the volume, as I said earlier, is proportional to temperature. So when V1 is divided by V2, V1 by V by T1 will give you T2 by V2 by T2. So this is a compressibility of Charles' law. When we talk about compressibility, we simply try to review the Charles' law, the definitions, and how this can be applied. Now look at this virtual representation. At constant pressure, the volume of a given mass of an ideal gas increases or decreases by the same factor as its temperature in Kelvin increases or decreases. When we talk about temperature in Kelvin, we know we have an absolute zero. The absolute temperature is given by negative 273. But now, if we are to convert this to Kelvin, any given value, you just need to add 273 to that value in order to convert it to Kelvin. So during the calculation, we will see how to do these conversions. As we see in this cylinder in the container, this is negative 65 degrees Celsius, and the second we have 250 degrees Celsius. To convert this, you simply need to add 273 in each of them in order to convert this temperature to that absolute in which we are going to have our answers in Kelvin state. Pressure law also shows the relation between pressure and temperature at constant volume. That is pressure law because the pressure of a fixed mass of a gas at constant volume is directly proportional to its absolute temperature. P simply represents pressure, and this sign is a sign of inversely. It represents inversibility. So it means that pressure is inversely proportional to temperature when volume is fixed. So P is inversely proportional to T. Therefore, P is equals to T, which will give us a constant. The graph of pressure against absolute temperature is a straight line graph like the one we have seen in Boyle's law. So it will be a straight line graph from the origin. Avogadro's principle explains the relationship between volume and molar mass when the pressure and the temperature are kept constant. Of course, equal volumes of gases contain the same number of molecules. So when we talk about molecules or particles, we are going to talk about the equal volumes of gases that is stored or being fixed in a container. They have the same number of molecules. So the V divided mathematically, we represent this idea by saying that the volume divided by the number of particles is going to remain constant because volume is proportional to the molar mass. So V1 divided by N1, which is the number of the molar mass, will be equals to V2 divided by N2. So this is a gas law which states that the total number of atoms or molecules molecules can be called atoms of a gas. That is, the amount of gaseous substance is directly proportional to the volume occupied by a gas at constant temperature and pressure. Avogadro's law is closely related to the ideal gas equation since it links temperature, it connects pressure and volume and the amount of substances for a given gas. So we use Avogadro's law when we want to talk about a kind of perfect gas or an ideal gas. So that is what we mean. This formula is being used to calculate the volume using the Avogadro's law. So we have V is directly proportional to N, so that our V divided by N will be K, which means constant. V is the volume of the gas, N denotes the amount of gaseous substance often expressed in mole, and K is a constant when the amount of gaseous substance is increased. The corresponding increase in the volume occupied by the gas can be calculated with the help of the following formulas that I have given. V1 divided by N1 is equals to V2 divided by N2. This is the K is constant as per Avogadro's law. So this is generally what we talk about when we talk about Avogadro's principle. So let us finally consider the Datums Law of Partial Pressure. The total pressure exerted by a homogeneous mixture of gases is equal to the sum of the partial pressures of the individual gases. The partial pressure of a gas is the pressure it would exert if all the other gases is in the mixture were absent. So when we are talking about the partial pressure of a gas, you should always remember we are talking about that pressure it could exert or that pressure it can generate if all the other gases in the mixture were absent. A limiting law is such a law that is strictly true in a certain limit. The law that the sum of the partial pressures equal to the total pressure is true for real and perfect gases. And when we talk about real or perfect gases, we are simply referring to ideal gases. So Dalton's law is only valid for perfect gases. Hence, it is a limiting law because we know, me and you know that we don't actually have that perfect gases. So this is limited and we cannot actually dwell there. But it's good to have an idea because during numericals and calculations, we will be applying Dalton's law of partial pressure. The combination of Boyle's law, Charles' law, and Avogadro's principle. We see that this explains how perfect gas equation of state arises by combination of Boyle's law, Charles' law, and Avogadro's principle. The perfect gas equation is an equation of state which relate all the variables that we already define the state of the system. Boyle's law, Charles, and Avogadro's established this relation for gases to low pressure, and that is perfect gases. Boyle's law simply means volume varies with pressure. Charles' law, volume will vary with temperature, and Avogadro's law, volume varies with the amount of gas. I hope you have enjoyed this video. Help us to help you as we continue to help you in your academic pursuit. See you in our next video as I will be taking you through the calculations that involve Charles' law, Boyle's law, Avogadro's principle, and Dalton's law of partial pressure. See you next time, and God bless you. Thank you.